The last 4 lessons we have talked about like calculation for linear equations, simplified expression, expanding, factorization, and we talk about the solving equations for linear and solve inequalities for linear. So this lesson we're going to learn how to sketch linear equations. Okay, how to sketch it. So what a linear looks like? Well, a linear is a line. Okay, it's a straight line. So first of all, we talk about the graphing straight lines. We have a linear equation with common form. There are 2 forms for linear. One form is y equals to mx plus c. This is called the gradient intercept form. This is called the gradient intercept form. So it's y equals to mx plus c. I forgot x here. This should be a half x minus 2. There's an x. Y equals to half x minus 2. So what is the m? What is the m? M is the gradient. M gives you the gradient. I'll talk about what is gradient later. And the intercept given by c, which is the y-intercept. Okay, it's not the x-intercept. It gives you the y-intercept. Because when you sub x equals to 0, you have y equals to c. So y-intercept is the c value. I'll talk about more about it. So this is a general expression for a linear equation. So y equals to mx plus c. For example, y equals to half x minus 2. That will be a linear equation. When you see things expressed in that form, you know this is a linear. The next form is a general form. The general form got some x plus some y equals to some constant. Okay, some x plus some y equals to some constant. For example, 3x plus negative 2y, and that equals to 6. That is linear as well. Okay, that is linear as well. So for any given straight line graph, the y value changes by a fixed amount for each 1 unit change in the x value. So if you just on a given linear, for example this one, from this point to this point, okay, for example that's 1 unit of x change, for example that's 1, and then we get some change in y value. Okay, so it moves to the right by 1 unit and it's moved up by, for example, that's 1 unit as well. Then if you choose any point here and then you move horizontally by 1 unit, if let's say this 1 unit, and then you reach another point, then the height, the change in height needs to be 1 unit as well. So in the same linear, if you change the same amount in x, then you will change the same amount in y as well. So each x change, how much y change, that will call the gradient. So the gradient tells me the rise over run. Okay, that's the formula. The gradient tells me the rise over run. So what's rise, what's run? Let's just look at those 2 points. Rise is the level you increase. Okay, the vertical level increase, that's the rise. Well, sometimes it could decrease. I'll show you the graph, it could decrease. And the run is how much your horizontal x change, like the x value change. So from the left-hand side point to the right-hand side point, how much get changed in the x. So that's the run. And the rise is the vertical increase or decrease. That's called the run. So the rise over run, it gives you how much y change in each unit x change. Okay, in each unit x change. So that will give me the gradient. That will give me the gradient. So we can have look at 4 types of linear equation. Okay, 4 types of linear equation. Well, you see this one on my thing. The blue one is positive gradient. With a positive gradient. Why with a positive gradient? If you choose any 2 points on this graph, okay, 1 here and 1 here, the run is positive. Well, run is always positive, which is the left point to the right point. But we have rise is a positive value. Okay, it's a positive rise and positive run. Then you will have a positive gradient. rise over run will give you the gradient. That's positive. Okay, let's think about the negative one, the red line. We select 2 points. We select 1 point here, and we select 1 point here. Okay, any 2 point on the graph, any 2 point on the graph. Overrun is this, and rise will be the vertical change. Here, see the run is a positive value, and then the rise will be a negative value. It's actually decreased from the left hand side to the right hand side. So you will have a negative over a positive. That's why you will have a negative gradient for the red graph. Because your run is always positive. Okay, run is always positive. You always have positive run. But the rise can decrease or you have increase, depends on different graphs. So therefore, for this type, you will call that a decreasing graph. Okay, the y value decreased when x increased. So the blue one is called an increasing graph because when x increased, y increased as well. So that's an increasing graph. Okay, let's have a think about the green one. Okay, the green one. We select any 2 points. Okay, the run is the horizontal change. Okay, the horizontal change. That's the horizontal change. That's the run. What do you think the rise is? What's the rise? 0. There's no rise. Okay, from this point to the second point, no rise. Rise is 0. Well, you can have whatever run you want. Okay, you can have 2 point here, 2 point here, 2 point really close. But doesn't matter which 2 point you take, there's always have a run of 0, a rise of 0. There's no rise, there's no change in the height. So we have 0 over run. So you always get 0. That's why the gradient for a horizontal line will be 0. Okay, the rise is 0, but whatever run I have, it doesn't matter. 0 divided by anything, you will have 0. Okay, 0 divided by anything, you will have 0. And let's look at the vertical one. Let's look at the vertical one. Let's look at the any 2 point. We select a point here, and we select a point here. Well, the vertical change is the run. Rise is the rise. What do you think the run is for this one? What's the run? Is there any x change in those 2 points? No. So the run equals to 0 in this graph. The run equals to 0. Well, any 2 point, there won't be any change in the x value. They all share the same x, but different y value. You can increase as much as you want. You can decrease as much as you want. But what you have now is rise over 0. What do you think the value will be? Undefined, not 0. 0 divided by anything will be 0, but anything divided by 0 will be undefined. Undefined. Because I can't evaluate that. No denominator equals to 0, which is undefined. So we don't have a gradient for the vertical line. So for this shape, we have positive gradient. For this shape, we have negative gradient. We have horizontal line, we have 0 gradient. But vertical line, we have gradient undefined. Okay, gradient undefined, which is not existent. Gradient undefined. Okay, so for the first question, let's have a look at the first question. Now we want to decide if the point -2 and 7 is on the line or not. Okay, it's on the given line or not. So what we need to do is a decide. Okay, decide question. So it's a proof question. That needs to go back to what we have before. So left hand side and right hand side. Left hand side and right hand side. we need to say when x equals to -2 and y equals to 7. We want to see if those two values can make the left hand side and right hand side to be the same or not. So my left hand side equals to y. Yeah. Well, you need to tell me what you're trying to test, like what's the testing value. So left hand side equals to y, and that equals to 7. Right hand side equals to -3x plus 1. That equals to -3 times -2, and then plus 1. And that equals to 7. So we have left hand side equals to right hand side. So this point can still hold the equation. Okay, still can hold the equation. So -2 and 7 is on the linear. Okay, that's what you should write. I know everyone can test it. Everyone know whether it's on the graph or not. But that's how you should express your answer. That's how you should communicate. Second one, 2x plus 2y equals to 1. Still, I will say when x equals to -2, y equals to 7. Left hand side equals to 2 times -2 plus 2 times 7. Substitute that in, and that's -4 plus 14. That gives me 10. Right hand side is just equals to 1. It's not changed with x, y values. Left hand side is not equals to right hand side. So -2, 7 is not on the linear. Or not on the graph. Or not in that equation. Alright, we have learned linear equations in year 9, right? We have learned the basic about like what the graph should look like. How many points do you need to draw a linear? 2. Okay, we need 2 points to sketch a linear. So let's have a look at the first one. What do you think the gradient will be? Positive, negative, or 0 and define? Positive. Okay, positive. So we have a positive. So we should have some graph looks like this. And well, if we need 2 points to sketch the linear, which 2 points you will find? Well, definitely what 0? Well, y equals to 0, that will give you what point? X-intercept. Yeah, we will have x-intercept. And what else? When x equals to 0, we have y-intercept. So if we can find x, y-intercept, that's the key feature we need to label for all the graphs. So if we can find those 2 points and then we connect them, that will be we can easily draw the linear. So let's do that. We'll say when x equals to 0, y will be -1. Right, sub-0 in, so it's 2 times 0 minus 1, and y equals to -1. And when y equals to 0, 0 equals to 2x minus 1, plus 1 on both sides, 1 equals to 2x, and x equals to 1/2. So when x equals to 0, y equals to -1, we have 0, -1. When x equals to a half, y equals to 0, you have half 0. So because it's a straight line, we can just connect it like this. To sketch a linear, okay, you must use ruler. Okay, you must use ruler, or you can use your student card if you want. But you must use some straight thing to sketch it. Okay, like that is not a linear. I will take the mark off. That's not a linear. That's some curve. It's not straight. Do you mean to scale? Well, I think normally axis will be given to you, but if not given to you, you should draw it like using. Well, if you have a ruler, better just use your ruler to sketch things for straight lines. Okay. Alright, one thing I want to mention to you is keep a good habit to label the graph. Okay, to label the graph. What do you mean by label? Label your graph. That's this graph. Okay, this blue graph is y equals to 2x minus 1. Okay, keep the equation there. Well, when there's only one graph to sketch, we don't really need to do that. But if there's more than one graph sketched in the same Cartesian plane, you need to label it clearly to make sure I understand which graph you're sketching. Okay, this graph is for this equation. This graph is for that equation. If you don't label equations when you draw multiple graphs, you will lose the mark. Okay, you will lose the mark, 1 mark for that. Because I don't know which one I'm trying to sketch. Okay, you need to keep a good habit to label your graph with the equation. So this graph is y equals to 2x minus 1. So we label that. Okay, second one. 2x plus 3y equals to 3. Okay, 2x plus 3y equals to 3. What kind of gradient we have for this question? So how do you know whether it's positive gradient or negative gradient? Sorry? Negative 3? Negative 2 over 3. We need to rearrange it first. We keep the 3y here and we minus 2x on each side of the equation. So we minus the 2x on each side of the equation. And then we need to divide 3 on everything. So what we have is y equals to negative 2 over 3x plus 1. So divide 3 on everything. Okay, divide 3 on everything. So that's in the gradient intercept form. That's in the gradient intercept form. So I can see my gradient is negative 2 over 3 and the y-intercept is 1. Okay, so that's a negative gradient. That's a negative gradient. But if I just want to find the xy intercept, I don't need to make it into the gradient intercept form, because I can say when x equals to 0, I'm trying to find the y-intercept. Okay, I'm trying to find the y-intercept. I just sub x equals to 0 into the original equation. I will have 3y equals to 3. Then y equals to 1. So 0, 1 will be the y-intercept. And then when I make y equals to 0, I can make y equals to 0. So 2x equals to 3. 2x equals to 3. And then x equals to 3 over 2. x equals to 3 over 2. So 3 over 2 comma 0 will be the x-intercept. So the point I want to make here is you don't need to make a particular form to find x-y-intercept. You can use any equation to sub x equals to 0, to sub y equals to 0 to find x-y-intercept. When you sub x equals to 0, the y value you get is always the y-intercept. When you sub y equals to 0, the x value you get is always the x-intercept. So that's what we can do. And we're trying to sketch for it. So we have 3 over 2 comma 0, and we have 0, 1. And we'll draw the linear by connecting the 2 points. So this equation is 2x plus 3y equals to 3. All right. The third one, y equals to 2. Do you think that's what kind of graph is that? I think we should learn that in year 9 already. It's a special type. Yeah, what is that called? So this is straight line. That is straight line. That is straight line. Horizontal straight line. Okay. Why is a horizontal straight line? All I need is the point with y equals to 2. Any point with y equals to 2. I don't care about x. X can be 0, can be 1, can be 2, can be 100, can be anything. So we can just select any x value. So obviously I will select x equals to 0. So I will select x equals to 0, but y equals to 2. That point is 0, 2, with y equals to 2. I can select any other point with x equals to, for example, 3. And then y equals to 2. All I need is y equals to 2. I don't really care about what x I have. By connecting them, you will have a horizontal gradient. Well, it's not really straight. Okay. That linear is y equals to 2. You have a horizontal line. Okay, you have a horizontal line. I only care about the y value. I only need the y value is 2. So all the point needs to have the same height, but can have different x. Therefore, we will have y equals to 2 as a horizontal line. Cut the y axis at 2. Cut the y axis at 2. All right. 4. Therefore, x equals to -1. What kind of graph it should be? A vertical line. So, well, what all I need is x equals to -1. I don't mind really my y value. What is my y value? So I can have -1, 0. That point. We have -1, 0. Well, I can also have -1, 4. Okay, I can have a point here. Any point. Okay, I just select, you can put -1, -2. Just need x to be -1. Therefore, you will have a vertical line, which is x equals to -1. And cut the x-axis at -1, 0 with a vertical line. What's the gradient for this one? Undefined, right? Undefined. And how about this one? Gradient 0 for horizontal, gradient undefined for vertical. All right, and if you can go to the next page, I want you to draw a flow chart with me. Okay, I think we have done. I remember while teaching and I did exactly the same thing. Find equations for linear with them as well. So I think it's kind of revision with you. And if you can't remember, we can just revise on this. I don't want you to go through point one, step number 1, step number 2. I want you to think about the flow chart. So the first question we want to know is, okay, do we, well, have gradient or not? Okay, do you know the gradient? Do you know the gradient M? So can you tell me what is the gradient? Okay, can you tell me what is the gradient? If yes, well, if it's yes, my question will be, do you know y-intercept? We can have yes and no as well. Do you know y-intercept C? Okay, let's say that's the y-intercept C. We have yes and no as well. And then we have no for this side. If we don't know the gradient, what we can do? Okay. That's the question box. That's the question box. So basically, we just ask ourselves 2 questions. Do we know the gradient? Do we know the y-intercept C? Okay, so if both question answer are yes, if both answer are yes, we know the gradient and we know the y-intercept, we can, too easy, we just write mx plus c, directly get the equation. We know the gradient, we know the y-intercept. Like instant, we have y equals mx plus c. How about if we don't know the gradient? We need to find gradient. Okay, how do we find gradient? M equals to y2 minus y1 over x2 minus x1. We have seen this equation. If you haven't seen it, we copy that down. That's the right overrun. We use the y value of one point to subtract the y value of another point, give you the change in the height. And then we subtract the x value. We get the change in the x. That gives me the rise over run. We got the gradient now. Now, yes, we have the gradient. And my next question will go here. Now, we know my gradient now. Do you know the y-intercept? Well, if you know the y-intercept, we write y equals to mx plus c. How about if we don't know the y-intercept? How about if we don't know the y-intercept? So, if we don't know the y-intercept, what we can do is one equation which is really helpful. Y minus y1 equals to mx minus x1. I hope everyone can remember this equation. What's the meaning of this equation? Here, that's the equation. They are both answers, okay? They are both answers. One is when you know the I need to know the gradient anyway. I must find the gradient. Well, it doesn't matter we know it at the beginning or we don't know it. But if we know the y-intercept, we use this formula to directly give the gradient-intercept form. If we don't know the y-intercept, we use this formula instead. What this formula means, x1, y1 is a point on the equation. Okay, x1, y1 is on the linear. any point on the linear. Okay, any point on the linear, which gives you x1 and y1. What is m? M is the gradient. M is the gradient. And you keep xy as xy. Xy is your variable. So then we will have the linear directly. I can have the linear directly. I'll show you one example. I want you to get familiar with the flow chart first. Okay, so that's what we can do. Okay, that's what we can do. So ask yourself 2 questions and then go through the correct pathway. Well, when we know it, when we don't know it, what we can do. Let's have a look. Well, then you can ignore everything we said here, 1, 2, 3, 4. Let's just have a look. Find the equation of the straight line showing here. The first question you ask yourself is, do you know the gradient? Yes or no? Yes? No? No, because it's not given to you explicitly. So what I should do, like, is a no. Then what I should do is use y2 minus y1 over x2 minus x1 to find the gradient. Okay, to find the gradient. So we can see this point is 1, 0. And we have another point, no, 0, 1, not 1, 0, 0, 1. And another point is 4, 13. So we can say this is x1, this is y1, this is x2, this is y2. We can label anything as x1, anything as x2. So you choose one point to label as x1, y1, and another one as x2, y2. So the gradient equals to y2 minus y1 over x2 minus x1. That gives me 13 minus 1 over 4 minus 0. That gives me 12 over 4 and equals to 3. The gradient is 3. For each x change, your y value will change by 3. Okay, for each x change, the y value will change by 3. Okay, we have our gradient now. What's our next question? Do we have y-intercept? Do we have it? What's the y-intercept? 1. You see that's there. That's 1. So we will directly write y equals to 3x plus 1. Y equals to mx plus c. So, yes? You can do substitution. You can. Definitely you can do whatever, like you can get the right answer. But this formula is prepare you for VCE. Like it's not saying you must use the formula to get right answer, but it's a quicker way in VCE exam if you know it. You can't avoid using it. Like in the end you will learn it. So that's why I put it here to make you to learn some new stuff and then try to remember some new formula. But you definitely can use the substitution to get the C value and then do it. Yeah. Well, for this question, there's no need of doing like substitution. We have the C already, so that's 1. Okay, let's have a look at the next one. If the gradient of a linear is a half, and the line is passing through the point 2, 1, find the equation. First question, do we know the gradient? Yeah, we know the gradient. Gradient is what? 1 over 2. Good. Next question, do we know the y-intercept? No. If we don't know the y-intercept, or recommend you can come to that formula y minus y1 equals to m times x minus x1. What is x1, y1? Is any point you know that is on this graph. So x1, y1 will be that. So x1 is 2, y1 is 1. So any point, okay, can be any point on this linear. So you know that point is on that linear. So what I will write now is, well, again, y minus y1 equals to gradient x minus x1. So I can substitute all the things we know now. So y minus 1 equals to a half times x minus 2. And we can rearrange it. Y equals to a half x minus 1 plus 1. Y equals to half x. plus it. So this 2 is by extension, and then the 1 plus to that side. So you can see, like, you can make y equals to half x plus c as well, and then solve for c by substitute the point x equals to y equals to 1. But this one we can directly get the equation. Okay, at once we directly get the equation. I think so. You can check the cross outline. Okay, example 3. Find the equation of the line drawing the pair of the points -3 and 8 and 5, -2. Okay, only 2 points is given. Do we know the gradient? No. Okay, if we don't know the gradient, what we can do? How we can find it? y2 minus y1 over x2 minus x1. I can make any pair becomes y2, y1. Like, I can say that's x2, y2, and that's x1, y1. Okay, or swap them, like x1, y1, x2, y2. That doesn't really matter. So what I will do is, gradient equals to y2 minus y1 over x2 minus x1. So y2 minus y1, so it's 8 minus -2 over x2 is -3 minus x1, which is 5. Okay, -3 minus 5. You must use y2 minus y1 and x2 minus x1. Not, well, you can't use y2 minus y1 and then x1 minus x2. That doesn't work. Okay, it must be the same pair in the vertical line, in the same vertical line. So what we have here is 10 over -8. That equals to -5 over 4. Do we know the y-intercept? No? No. Okay, we don't have 0, something, so we don't know the y-intercept. If we don't know the y-intercept, we'll use y minus y1 equals to mx minus x1. So we have y minus y1. My y1 is -2. So y minus -2 equals to gradient is -5 over 4. X minus x1, which is 5. So x minus 5. It will be exactly the same if you make the other pair becomes x1, y1. So you can use the other point as well. So any pair of points on the linear will work for this equation. So, well, because I have made x1, y1 for the second pair, then I'll just sub that in. So y plus 2 equals to -5 over 4x plus 25 over 4. Y equals to -5 over 4x plus 25 over 4 minus 2, which is -8 over 4. So -2, which is same as -8 over 4. So y equals to -5 over 4x plus 17 over 4. But make y to be the subject. To rearrange the equation, make it look like mx plus c. mx plus c. Yes? Yep. That's right. Is that different from what you solve by substitution? There's no y-intercept given. There's no y-intercept given, so it's c value. So what I find out, the c value is 17 over 4 in the end. but it's not given originally in the question. That's why I'm using y minus y1 equals to m times x minus x1. Yes? You will get the mark. Like, as any method you get it right, that will give you the mark. So all the method will be fine. Okay, any questions? Any questions? Okay, if you don't have any questions, we complete YF already, so your homework needs to be up to date. But we don't have class on Thursday. We have digital delivery day on Friday, which you need to complete your homework task. As I mentioned, I will give you the link, and you do that within the period, and you send me a photo of your completion of work through email, and you give me a hard copy when you come back on Monday. So you see the email? I'll send it. No, not this one. It's a homework task. You know the one link? I extend this to 1:30 to make you submit. Our class is in period 3, so I make a little longer time for you to do it.